Welcome to the second video for section 5.7, solving radical equations. We are going to do one more example in this video where we solve for x when we have radicals. This one I'm calling spicy for the only reason that we have a radical in two different spots. We have a radical on the left side of the equation and we have a radical on the right side of the equation. When we do this, we're still going to take the same approach and we're going to attempt to isolate one of the radicals. And I look and I see the one on the right here is already isolated alone. So let's get rid of that radical first and then we'll worry about this guy here on the left later. So how do you get rid of a radical? Is you square it, and what you do to one side of an equation you have to do to the other. So it gets a little tricky here on the left. There's a binomial now times a binomial. 3 minus root x squared is really 3 minus root x times 3 minus root x. And then on the right side, the root and the exponent of 2 just cancel each other out. So we're just left with an x minus 3. So I actually, on the left-hand side, I'm going to have to do a little bit of FOIL work. But instead of foiling it, I'm going to practice using my area model method instead over here on the right. So I have a 3 and a negative root x, a 3 and a negative root x. And let's go ahead and simplify this. 3 times 3 is 9. 3 times a negative root x is a negative 3 root x. I have another negative 3 root x. And then a negative root x times a negative root x is a positive x. Because the negative times the negative becomes a positive, and then you have a square root of x times itself, which is squared. The exponent of 2 and the radical will cancel. So I'm looking now, I see I've got like terms here and here. So when I rewrite this, I'm going to have my x, then a negative 6 root x plus 9, and then I still have this equals x minus 3. All right. So now when I keep going, I'm liking this because one radical is gone. Now I just have to worry about this one here. So let's go back to the idea of let's isolate the radical again. So to get that x alone, I'm going to subtract x from both sides, and I'm going to subtract 9 from both sides. So I end up with a negative 6 root x on the left. Oh, and then what's really kind of nice is these x's cancel, and I'm left with a negative 12. All right, I'm almost there. This negative 6 is multiplying the root x, so I'm going to divide. So I have a root x equals a positive 2. So now the only thing left to do to get rid of that radical is to square both sides. So I'm left with an x equals 4. It's really tempting to quit and be done, but I need to take some time to make sure that that answer is correct. So I'm going to check my work. Every time I see an x, I'm going to replace it with a 4. And now let's simplify both sides. And remember, when we take the roots, we only take the positive version. So I'm going to have a 3 minus, the square root of 4 is 2. And then over here, 4 minus 3 is 1. 3 minus 2 is 1, and the square root of 1 is 1. It's a true statement to say 1 equals 1, so I am going to accept x equals 4 as an answer.